your product, the h-aero stuff, it's truly amazing technology. Now, here in a minute, you're going to let me fly the one that's behind you, right?
Right. That's
okay.
it.
All right.
So you said there is a camera system under it. Actually, there can be anything under it because we created a universal receptacle. So here under this system is a computer. It's a hovering cybernetic unit to collect data from the air. And we are using these systems mainly indoors at the moment for airports, for example, or tunnels. Yeah, thank you for the video.
Yeah, here it is in action.
Here is our Chancellor. We have 3 different sizes. This is the biggest one, 600 watts.
Wow.
In the second one, so this is a little horse. There you saw already photogrammetric skills. Here we are broadcasting one of the biggest events, Intergeo, one of the lead fairs for Earth observation.
Wow.
Then we are here inspecting a tunnel.
This is really amazing technology, and it seems such a simple and elegant idea. I mean, like,
yes, it does.
You would think that there'd be a lot of competition with this, but you guys are pretty much it. This is absolutely stunning, and it's going to really open up the world of aerial photography and everything that you can do with a regular drone. You can do longer and extended flights, and you can fly over people. There's so many pluses to this.
Nobody gets offended.
Yeah, right. Yeah.
From a part, it's right. From the other part, it's, let's say there's an Alawach that came down, and you wouldn't do it with an h-aero, then you would more go out with a drone. So we are more in symbiosis with drones. That means we start there where they're more or less stop, and we compete more with satellites and manned systems like helicopters and Cessnas, where you can use our systems. So the systems are already communicating over mobile network and satellites. So we can also find a plastic carpet out there.
Yeah. So this does pretty much everything that a propeller drone will do. It can maneuver itself around. It's GPS locked in place, right? I mean, it does all of the things. What kind of cameras can it carry?
Oh, we have here very strong broadcasting cameras up to 4 or 8K until we are under 500 gram, 1 kilogram or 3 kilograms. I said we have 3 different sizes. Everything's fine. Included to these masses are already also the batteries. We calculate the battery into the payload. This is, let's say, a certain approach how we used to do it.
Okay.
Because yeah, this is our ballast or a ballast that we for ballast we used to take energy in form of a heavier battery.
Okay,
that's a good idea.
Now you are looking for investors for this. Am I correct?
Yeah, that's right. Like we are one of relatively strong visibility startups for aerospace and sustainability here in Europe. And yeah, of course, we want to come out of our bootstrapping mode and come to business. The product is now developed, and now comes, the 4 Ps.
Wonderful. And I have so many more questions. And if you have a question for Csaba in the chat, please ask away. And Tater, keep an eye on the questions and let me know what the questions are. But I'm actually looking now through the link that you gave me.
All right, so hold on, so that the audience can see the system. I will now help you. You will now use the autonomous control system. We have also a manual, and now as I saw how strong you are, next time you can also use the manual control, but this time let's start with the autonomous one.
So I'm hooking up to remotely, and I'm gonna fly a drone airship from
that thing's bigger than I thought it would be.
The United States. Yeah, look at this. He's setting it up.
That's so cool.
Yeah.
All right, let's go.
All right. So I remember I start off with liftoff, right?
Yes.
Okay, I'm going to click liftoff.
On the bottom left, you see the target values that can be changed with up and down.
Yes.
With like the AGL above ground level and the compass, which
Right.
is the direction of the system.
And so
At
it's
the
going up.
beginning, the
There it
system
goes.
is calibrating itself.
This is so wild. This is great.
And actually, the data that is collected is also sent to a cloud server and visualized there already in diagrams, also for universities and research and development. It's a good tool to test your new servos that you developed for the digital transformation.
Right. Okay. So I'm going to use the interface, but I'm going to show. Okay. So I'm going to go forward. I'm going to click forward and have it bump into the back of your head. That's what I'm going to do. I'm clicking forward now. And so,
you are coming closer. Cool.
I am. Yeah, here we go. Coming towards you.
Watch your hand.
This is so wild, man. I love it. I love it. Wait to put the camera on. Let me put the camera back on. There we go. So we can see him.
Oh,
So
wow.
imagine that you control this system from the ground station of an airport, so the people don't need to walk around.
Yeah.
You can have a beamer and beam a face here, and the face is talking to you like, is this your luggage behind you?
Right. There's so many applications for this, and of course, we're just using a regular internet connection. There's going to be better connections, satellite, maybe 5G eventually, where it would be in actual real time. So you can do what I'm doing. Your customers can do exactly what I'm doing from other locations, other countries. Let me go ahead. I'm going to go forward again. I'm going to click forward again. And I know
What
it's
you could do is looking like, where is our north? So just turning around from 180 to 360, for example.
yeah.
Or would be a nice challenge. I heard you want to make challenges, so like to fly to the window and looking out of the window how it looks like in Baden-Baden, Germany.
Okay, yeah, let me see. So I'm going to have to I'm going to go forward again. So it goes forward by the increments that you set in the bottom left. Is that right?
Yes, so hold on. There again, some little thing happened, what sometimes used to happen.
That's
You
okay.
need to correct the system quickly.
Yeah, this is all just amazing that it even
We
works like
have
this.
sometimes little, let's say, children illnesses. So
Oh, yeah.
Little viruses. Yeah.
also
So let
for
me,
what we used to need the funds
yeah.
to make this even better.
This is so amazing. Did I just land it?
No, this was me, and I'm more or less starting again to
Okay.
restart the
We got a
system
ton of
quickly.
questions coming in.
Yeah, what kind of questions we got, Tater? Go
Starting
ahead.
again.
Ben Cartwright wants to know, how much do you expect consumer price to be when it's ready to go?
The consumer price is starting around 8,900 euros. Around is a bit under $10,000.
Okay.
Okay.
And
And here
TriPro,
already a 4K camera is inside, and
Okay.
the system is fully open for adoption. And if it comes, let's say, with a board computer, there's a bit more, and then we can make it open source and so on. So
you
now
pretty
you are
much-
looking to north.
Yeah.
You still.
you can spec this out pretty much however you want, depending on your use case.
Exactly. So like a computer, you can configure it in a different way. We can. Funny thing is also to understand this point really in its spectrum. The first thing that we carried around was over a catwalk. It were clothes
Okay.
to
That's
promote a product.
Right.
a good idea.
And if it's electronics, everything what's possible, even multimodal sensors with cognitive behavior. This is on which applications we work on in research projects, inspecting airplanes, for example.
What kind
Wow.
of I have a question. What kind of who is your governing body there? You're in Germany right now, but who is the governing body? Like, what is the equivalent to the United States FAA, and how is this regulated? Is it similar to drones in that you'll need a license and all that? What kind of
All right. So we have here new regulations in Europe, which started to be new from the start of this year, 1st of January. And we have classifications. The systems need here CE certificates, which are consumer certificates. And there you write more or less which standards you use and which are more or less applied in your drone. And then there are classifications which are connected to the maximum takeoff mass. And the funny thing is, because we have helium, and maximum takeoff mass is sometimes 200 to 0 grams even.
Right.
Like when the system is made, like we have a degree of freedom that we can make it float passively.
Yeah, you can make it
any energy just for maneuvering.
Neutrally buoyant.
We are C00, which is, let's say, we are allowed to do the most, of course, because we have also already a passively open parachute, as you see it very obviously. And at the same time, I combine these three flight concepts, balloon, helicopter, and airplane, into one. But at the same time, it's also a parachute or a kite. We don't need to hold position always with power. If we use, let's say, a little bit our intelligence, then we use a rope. And the rope is even powering up the system with electricity. So the battery stays then down if it's in a kite mode.
I'm going to go ahead and land, okay?
All right.
Okay.
While he's doing that, I got a couple other questions. I've been actually watching this before. I watched your crowdsourcing video on this, and I watched how you printed a lot of the 3D parts for it, and that was one of the really cool things about it. The solar panels that you guys acquired at the beginning of August that you said you're testing, how's the testing going? Is it going to work out as good as you think it is?
All right. Here, this is also a funny question and good question. The tests are on that way that it is in the mock-up mode. And we have the next milestone is a release and catch. So let the system go in the BV loss mode and tracking it over satellites, getting the data back after landing, so catching the data. And then the next step is to go to do this for 24/7. And there we will need then the solar cells, which are already produced in the testing. It has a little recharger because lithium polymer batteries are the ones which we use, and there must be a balanced charging from the PV. This is more or less all work in progress. The system, the solar cells are prototypes, and let's say the first fabrication you don't really like to have in the air very quickly. So I'm looking to reproduce, to have a second one. You know, also this rule, always have two, and then it comes into the air.
I love it. I watched a little bit of this where it was doing the Sistine Chapel or something, where it was getting some really good close-ups of the artwork for restoration purposes and for virtual tours for people. And I also noticed that it has a 6-hour flight time. Is what you're thinking, 5 or 6 hours in the air?
Yeah, the biggest one. See, we have also here again, let's say, a degree of freedom. To explain this, I'm coming to another discipline. Do you know in diving the curves of how long you are allowed to, and they are different, related to many, many different parameters. And let's say this kind of degree of freedom we have too. That means if you have the system in floating mode, passively floating, then you just use the electronics, and you can imagine how long. So it's an easy calculation, how you always used to calculate over the P is U times I, and then this way you get out how long. And of course, if we are in the floating mode, we can even do longer than 6 hours. And this will be more or less also this terrestrial or pseudo-satellite modes that we are accessing this year with our research and development and tests.
This is so great. I have a question that's not in the chat. It's just a personal question. Csaba, may I have one to play with for a while, please? Will you send me one?
Depends. It's very good for promotion. So if we find good sponsors, let's do it.
All right. I didn't mean to put you on the spot. I was half kidding, but I think everybody in the chat wants one. Yeah, everybody in the chat's like, I want one of those.
One of the questions that was in there was, how often do you have to top off the helium?
This is an amazing question. As you know, when we were children, a little balloon came down after one day. So the helium diffusion is, let's say, for lighter than air systems, a problem. And here in Europe, there were many different developments on this area, so the people also took care of the foil. And we have here multi-layer foils, which lower the diffusion rate to a certain level. Also here, you know that now, if you go to a fiesta, you get some aluminum vaporized foil balloons for the kids.
Yeah.
And they come down after 7 days. Our systems and our balloons in the children's size come down after 30 days. So again, a factor of 5. We can almost conserve helium.
Wow.
That means with €100, we hold a system the whole year, flight ready.
That's amazing.
Speaking of helium, maybe too little too late, but I would like to apologize on behalf of the United States for not letting you guys, Germany, have helium back when the whole Hindenburg thing was happening. Our bad. Sorry about that. It was partly our fault for it exploding, right?
This is okay. So I'm actually from Hungary.
Yes.
I don't have much to do with that, but we use a system where we really use very small amounts of helium. So we can have already swarms with these types. And this is already a very interesting point, that helium is still worldwide a strategic gas. This is right. But on the other side, it is now allowed here in Europe to research again with hydrogen in the lighter than air, because it has a very, very huge application field. For example, over ocean areas, when you are not over cities, when there is not a big danger, and when it's autonomous unmanned systems, we can use helium, we can use methane, we can use many different lighter than air gases, which have different properties.
Now, in the United States, I could go down to Walmart and get a party balloon tank and fill up party balloons. Is helium as readily available in Europe as it is here?
Worldwide, in each big city, it's an industrial gas. You cannot live without helium.
Yeah,
anymore.
okay,
Everything is produced with helium. So it's like also, it's funny, also the same with hydrogen. You get hydrogen everywhere, and there are very strong safety standards, but of course, to follow these standards is effort and therefore costs. One has to take this into account. But depending on the use case, this can be very, very interesting. Imagine we fly with a hydrogen type balloon into a hurricane, measure the data there, send it to the supercomputer, and then we know that the hurricane is not landing somewhere in...
It's like Dorothy on Twitter.
Was it? Do you remember?
How many cubic cubic meters of
it starts with 2, the smallest one, then 3, and the biggest one 9. And also here, if you compare it with other lighter than air UAVs worldwide, we have still a factor of 2, which we feel smaller.
Okay, and so your largest drone is able to lift how much weight?
3 kilos.
Yeah,
Okay.
so 6 pounds.
6 pounds.
something.
That's not quite toddler ready, but could you lift small children with one?
The next level we reach is 5 kilo, and then it will be 25. So we, of course, raise our level, and we look much stronger for the learning curve than to be very huge very quickly, because this is what's not existing today, the scaling algorithms of lighter than air.
Yeah.
This is a worldwide question, and we are now on the bleeding edge of technology in this talk.
This is leading edge. This is amazing.
It really is.
And I just thought, you've thought of all the applications, but farmers could really use something like this, because they need extended flight times to map their field, to track their livestock, all kinds of things. Now, I understand that, it's going to be a costly thing initially, and you're going to really go for businesses. Industrial application. Will you eventually possibly come out with a consumer edition where, guys like us could have something affordable for?
Yeah, you are profis. Yes, this is absolutely right. Even a smaller system is in development, because let's say in the field of education, you can explain with such a device Leonardo da Vinci, Archimedes, Otto Lilienthal, and at the same time the children can start to program with 6 in the classroom, and they have no danger at all.
Yeah,
and it started out as a Raspberry Pi on board, isn't that right? And
why not? We have also other ones. It goes up to the NVIDIA Jetson TX, depending if we are carrying a hyperspectral camera or just an ultrasonic sensor for testing.
What about your wind? Have you tested it outside with the wind to see kind of how much it can deal with?
Yeah, it's also a good question. So as you realize, we are thinking sustainable. So we want to use the wind to come forward. So we use the meteorology and then we go outside. It's the one point. The other point is if we want to have a position holding feature, this is not always necessary to have a free flight then. So then we use the kite mode. And of course, this is an option to make the motors stronger and make the system more aerodynamic. This is for an aerospace engineer always an option, but this is a straightforward option, and we are more interested in the questions which are not solved yet.
Yeah, I keep thinking of the regulations here in the United States.
Yeah.
There was an FAA protest that I was involved with in Washington D.C. for remote ID that I was last year, and of course you can't fly any kind of drone in the Washington D.C. airspace. It's one of the worst airspaces to try to fly a drone in. So what I wanted to do to get some aerial photography was tie a camera to a giant helium balloon, which you can get one of those 6-foot round just balloons. Well, somebody told me that the FAA actually has regulations for balloons, so I'm thinking that this might either fall under the balloon category or in the very teeny tiny blimp category. But I also saw in some of your videos that you can't. I'm not flying it again by accident, am I? I heard it.
Someone's just lifted off, but why not? Let's do it. Maybe someone saw the link.
Maybe
but it works.
Maybe
we
are
safe.
Okay, I'm gonna hit touchdown, and then I'm gonna log off of that.
It just directly worked without any latency.
I think it would fall into a gray area at first until the FAA could figure out what the heck is this. Is this a drone? Is it a blimp? Is it a kite?
All right, hold on. Like it is absolutely a gray area because we combine the 3 flight concepts, and this also gives new flight patterns. And it's often, if it's the maximum takeoff mass or the other, let's say, parameters, we can change many things. But like if you just take off the motors, you win directly on an additional 300 grams, and then it's a balloon. Then.
Right,
Wow.
and you can have it be tethered. I mean, you can tether the thing. So, anyway, do we have any more?
This is, by the way, how we flew over the canceller, because there in this room also, of course, we have highest regulations, and we can take care of them. There are also questions related to this. How do you deal with security? Here, for example, it's an important point that the mobile network will be the infrastructure of, let's say, city taxis or aerial taxis. And this is also something which we don't know yet, where the altitude-specific field strength, and this is, for example, a task for us to define this volume.
Right. Are there any more questions, Tater, that we can?
Yeah, they were asking. A couple of people were asking about extra parts that you 3D print parts. So would that be something?
Of course, we use, let's say, all technologies that we can use to be as feasible and sustainable. So, like an aerospace, let's say, research institute. Of course, we use not just the 3D printer. We have of each part. Parameters, CAD models, and they are all calculated with algorithms. So we lay out the systems after the rules of aerospace engineering, calculate them, build them up, measuring, comparing the formulas with the results, get better.
Man.
What are you using for your telemetry and what do you use for a controller? Is it just regular?
Everything what we can just get. So we also used to try different systems. E2C, E2C sensors are very feasible for the board computers that we use. So the more easy to adapt, the more developed, the less expensive. Of course, these are the ones that we use to adapt and include. And the customers, as you understand, there are many, many use cases. So anyway, the customer is pulling us towards the technological development. So this is not we who dictate this. We
Right.
try, but it's in our mode where we are at the moment. We need to earn money with this also to come forward, and then the customer says what he wants to get.
Do you have
With the investor, of course, we will be able to go our roadmap more how we want to.
So you're optimistic for the future, but you do need investors. I put links in the
It's
description.
aerospace engineering, of course, we need investors.
Yes,
I'm
We want
seeing
to
Blade
share this.
Runner.
It's a big cake, and it's a big shareable cake.
and so if somebody would like to invest, if we got deep pockets, they can just go to your website and contact you.
Yes, please do it. Let's create a better
here.
world. So this system is not for military, it's for civil applications, planetary protection.
Okay, wonderful,
That
wonderful.
reminds me of Blade Runner in the future, where they got all those signs floating around for different businesses and stuff.
We start, and this is a global research field, of course, and all the people, the whole consortium, everybody who works on this, we are more or less starting to open up the third dimension for humankind. You can even have platforms later, live there in the skies, get water from the clouds, and have more space here.
So awesome, so awesome.
Yep.
Thank you for being on with us and giving us a little bit of insight into something that seems like it should already exist. You know what I mean? But hey, if you want to send me one, you can. I'll take care of it. I'll give you
Sure, we'll find a way.
But
When you make a toy one, I'll try the toy.
yeah, get a little toy one. But Csaba Singer, CEO and co-founder of h-aero.
Hybrid airplane technologies, yes.
There you go. Thank
you, Csaba.
very, very, very much. If anybody has any further questions later, you can email me here, kenheronupload@gmail.com. I can put you in touch with them. And thank you so much for staying up.
Write us to fly@h-aero.com. Thank you, guys. It was amazing. You have an amazing show.
Thank you, sir. Thank you very much. And now you can go to sleep, because I imagine it's like 3 a.m. there.
All right.
All right. I'll see you later.
Bye, sir.
you.
Okay.
Take care.
Bye together. Thank you so much.